Vectors in the coordinate plane. How do we find the magnitude? How do we find a magnitude? Magnitude of xy means we're going to write it as what? Magnitude of xy is the absolute value, isn't it? The formula for finding the magnitude, guys, we've done this before, is just the distance formula, okay? That would be x sub 2 minus x sub 1 squared plus y sub 2 minus y sub 1 squared. In other words, how do we find it when it's not in standard position, right? So if it's not in standard position, we have to actually subtract the x's and square them, subtract the y's and square them. And guys, it does not matter what order you put them in. I could do x sub 1 minus x sub 2 and y sub 1 minus y sub 2. Why does it not matter which order I subtract in here? What am I doing after I'm subtracting? So what happens when you square a positive? Positive. And what happens if you square a negative? So do you see that the order doesn't matter? You just have to subtract the x's and square them, subtract the y's and square them, add them together, take the square root. Do you understand how the formula we just used for the magnitude? If it's in standard position, one of the points is going to be 0, 0, isn't it? So do you see why it becomes a squared plus b squared? Because one of those pieces just goes away. All right, so let's look at this, though. Let's actually graph these 2 points, and see if we can find the distance. So if I want to use the magnitude of xy, initial point is at 2, negative 3. So this is point x. Point y is at negative 4, 2. So this is y. And I draw the vector in. Remember, it goes from initial to terminal. And yes, it does matter which way that thing points, okay? In vectors, the direction does matter. So now the nice thing is there's a shortcut to this if you want to use it. And I'll show it to you in a minute. So if we want to find the absolute value of xy, which is we need to take x sub 2. See, this is x sub 2, this is x sub 1, right? So we're going to take negative 4 and subtract 2 from it, square it. And then we're going to take y sub 2 and y sub 1. So we're going to take 2 minus negative 3 and square it. So we get the square root of, that's negative 6. This becomes 5, doesn't it? So 36 plus 25. That ends up being the square root of 61, which is approximately 7.8. Now, you can make sign errors here, can't you? Now, if you can graph these guys, you can skip all of that hard math, because I want you to think about something. If we turn this thing into a right triangle, this is 1, 2, 3, 4, 5 units long, isn't it? And this is 1, 2, 3, 4, 5, 6 units long. Well, look what we found here. Do you see how it corresponds? So if you have graph paper and you can't remember the formula, you can always just plot it, make your triangle, and make it work. Okay? Now, how do we represent this guy as an ordered pair? How do we represent xy as an ordered pair if we wanted to do it in standard form? We would use these two things right here. The only difference is that I would have to go this direction. My x would have to have a direction, and then my y would have to have a direction, wouldn't it? So this is really negative 6. In other words, to go from x to y, I would have to go back 6 places and up 5, wouldn't I? Do you see it? So this represents my A, and this represents my B in my standard form. So xy, the vector xy could be written as -6, 5. Or -6i hat plus 5j. Does that make sense? Yes? Okay. What about adding vectors? Can you add s plus t for me? How would I do s plus t? Take s. That's s, isn't it? T. We've done this already once, guys. And what do I get? Yep. 3, 5. So s plus t is the vector 3, 5. All right, what about 3s plus t? This is distributive, isn't it? So we get what here? 12, 6 plus -1, 3 gives me what? 11, 9. Yeah. 11, 9. All right. So why don't you try a couple? Try one. And if you get one right, maybe we won't move on to 2. And we'll just do the 1 because you'll have plenty of time left to do some homework in class, I hope, once we go to homework. So try 1. Find the component form and the magnitude. And remember, if you'll just go ahead and find the magnitude first, the component form pieces come out while you're doing that calculation, don't they? Yeah. If you do the calculations. You see where you can find the components in that formula? So as long as you write it out, the component form falls right out of the formula, doesn't it?
Yeah, can you scroll up? I think I wrote the formula wrong. X2 minus X1. That's what I wrote.
Y sub 2 minus Y sub 1.
Yeah, that's what I wrote. X2.
Is 52.
Oh, I did.
X sub 1.
Minus 12.
Oh, yeah, X sub 1, Y sub 1. X sub 2, y sub 2. Huh?
Oh, I did it wrong. That's fine.
84.
All right, let's try another one. Since some people had some trouble in that one, try number 2. Yep, just label them.
How's your day, Miss Duffy? I forgot to ask.
Pretty good. How's yours? Good. All right. How we do? Do pretty good? All right, so let's try a couple more of these down here. Why don't you try number 5, 2g plus h for me. So try number 5. Super easy, isn't it? All right. Is everybody good?
Stay like this.
Miss Duffy,
Pretty
is
much.
component form, will you just put it inside the arrow thingies?
Yeah.
Alright, now you have it.
Component form is inside the arrows. Linear form is where you take it out. Linear combination is when you take it out of the component form and put an I and a J in front of the A and the B. In other words, the linear combination would be 47I plus 39J. So this is component form. And this is a linear combination, right? Okay. Now, try number 6. Let's do one that's tough. F minus 2 times G plus 2H. See if you get it. Order
What's in the parentheses first?
parentheses first, and then multiplication, and then addition and subtraction. make it out like it's the worst thing in the world, and it's really not that bad.
What confuses me is like whatever these are called.
The brackets, the little pointed brackets,
It makes it look like it's a lie.
it does, and yet it's not. You just got to watch your signs and stuff, don't you? And do things using order of operations. That's it. Okay? So.
Oh, okay. I see what I did wrong.
All right.
Dang, brother. Hey, right. It takes so long.
I know. All right. What is a unit vector? Remember we said a unit vector is a vector that has a magnitude of 1 unit. Kind of like unit circle, right? Radius of 1. So how do we find a unit vector? I want you to look at something here. First things first is, in the direction of the positive x-axis, it's 1, 0, because it's just on the x-axis. In the direction of the y-axis, it's going to be 0, 1. In other words, guys, I hat is equal to 1, 0. J hat is equal to 0, 1. And if we had a third dimension, k, it would be 0, 0, 1. Okay? Now, how do we find a unit vector? There is a formula for it. The unit vector u is equal to the magnitude of the vector times the vector. In other words, I want to be able to write it in I hat, J hat form. So the first thing we have to do, in other words, we're going to take the vector v and divide it by its magnitude. If we take something and divide it by its magnitude, we're pretty much, something divided by itself is 1. So you get the general idea? Okay, so what we're saying, though, is the magnitude will be 1. All right, so let's find the magnitude of v. So the first thing we have to do is take this vector v and find the magnitude. We do that by taking the first term and square it, and square it. We know how to do this already. So this becomes the square root of 17. So now, to find the unit vector, we are simply going to take 1 over 17 and multiply it by the vector v. So this becomes, well, square root of 17, excuse me. This becomes negative 4 over root 17, right? Because we're just going to distribute it. And then negative 1 over root 17. Now, we can't leave that vector in the bottom, can we? Can't leave the radical in the denominator, so we end up with negative 4 root over 17 and negative 1 root 17 over 17. That's all there is to it. You find the magnitude, and then you take each of the terms and divide them by the magnitude. Okay? Now, the cool thing is that this ends up being kind of like the I hat, J hat part. Okay? This can be written as something I hat, something J hat. Okay? So let's actually go through and look at a few. It says find the components of MP. We've got an initial point 22 and a terminal point 54. So the first thing we have to do is find its component form, don't we? Do you agree? So how do we find the component form of MP? We got to figure out how far it goes. How far do we go from 2 to 5? Yeah, it's like subtracting. So we're going to do 5 minus 2. And then how far do we go from 2 to 4? So we do 4 minus 2. In other words, we have a formula to find the component form of any vector, we're simply going to take x sub 2 minus x sub 1, y sub 2 minus y sub 1. Boy, this should look familiar. Isn't this what we did as part of our finding the magnitude formula? Doesn't it make sense? That's where it's coming from. So we know the component form of this vector is going to be 3, 2, isn't it? Then it says rewrite as a linear combination. Okay. Linear combination simply means take the a and the b and turn it into a sub I plus b sub j. So we're going to take 3, 2, and it is going to become what? Plus 2j. Yes. And it has that goofy little hat because it's a vector, isn't it? It's a unit vector. All right. So let's try a couple of these. See if you can find the unit vector for P. Remember what you have to do. What do we have to find first when we're doing the unit vector? Magnitude. So find the magnitude and then divide each of the terms by the magnitude. See if you can do that for number 1 here. Did you get a magnitude of 5? Okay, so unit vector is always u. So the unit vector is going to be what? No, we don't multiply, we do what? Remember what unit vector said, it's 1 over v. So effectively we are dividing, aren't we?
It's 4 over 5?
Yep. Yep, 4 over 5 and negative 3 over 5. Make sure you make a note of that so you know. 1 over something, multiplying by 1 over something is the same as dividing, isn't it? All right. Try 2. See if you can find this one. Find the unit vector. Now here's the problem though. What happens if it's something that can be simplified? Can 725, square root of 725 be simplified? What could we divide 725 by? By 25, right? So how many times will 25 go into 725? Okay, so this would end up being 5 root 29. So if you can simplify, you need to. So now we would do this by saying this is what? 10 over 5 root 29. 25 over, and then we're going to simplify, aren't we? 5 goes into 10 twice. 5 goes into 25 5 times. So this ends up being what?
2 root 29.
And okay. Not so tough, is it? All right. Is everybody comfortable with this? All right, so try finding the next section. Try finding the given the initial and terminal points, try writing it as a linear combination of I and j, which means you got to first find its component form, don't you? And then from component form, we make it linear form, don't we? Linear combination. So find its component form. All right, what'd you get?
Negative 75
Minus 11j? Okay. How'd you do? Good? Anybody need to see it? Okay, so let's do a little bit of reviewing, and then we're going to try a word problem. And we'll give you a word problem. We're going to try it. We got to remember how to do applications, don't we? All right. How do we find component form given a magnitude and a direction? We've done this, guys. We did this last time. A is just the X and B is just the Y, isn't it? Don't we have a formula for that? Yeah. So our A is going to be what?
18.
Yep. And B is going to be 18 sine 240. And guys, guess what? If these are unit circle angles, you should do the unit circle thing. But I'll be nice to you and let you use your calculator for now, since we're doing real world applications. So what is 18 cosine 240? Negative 9. And what is 18 sine 240? Negative 15 point what? 6? All right, so how do we write that as in component form? We literally just put it in the pointed brackets, okay? So why don't you try 6 on your own and find the component form. All right, so how do we go from component form to direction and angle? Guys, we've done this too. It's just wording it a little differently. You know how to do this. This is my A, and this is my B, isn't it? So let's first start by putting it in component form. Component form would be -4, 2, wouldn't it? So what quadrant would that be in? This is going to be important. Second quadrant, quadrant 2. Because remember, our calculator will only give us quadrant 1 and quadrant 4 angles, won't it? So we're going to have to adjust this. It's going to give it to us as a 4th quadrant angle, and we're going to have to adjust it by adding what? How do we go from the 4th to the 2nd? 180, or pi, yeah. Okay, so how do we find the magnitude? Yeah. Yep. -4 squared is 16, plus 2 squared is 20, right? So square root of 20 would be 2 root 5, right? And then how do we find our angle? Inverse tangent of what? B over A. So 2 over -4. So what do you get when you do the negative tangent, or inverse tangent? Second tan of -2 over 4. I got -26.6, right? But I can't write that. So what do I add to it? Yeah. So add 180 to it. And we get okay. So why don't you guys try number 8 on your own? Find the magnitude and direction. Did you get it? Okay. So let's actually look at an application here. It's a physics application. I love this. Did you know that friction and normal force? Friction is basically how much the ground grips something, or how much one surface grips another. It's the reason why when you rub your hands together, they get warm. Okay? They're gripping each other. There's little bitty ridges that rub across each other, aren't there? Okay? So that's friction. When you walk because there's friction. So it keeps you from sliding across the floor. That's why you slip and slide on ice, because there's not any friction. You can't walk without friction. Friction, however, is a product of what we call the normal force. Normal force is what keeps that calculator from falling through. It pushes down on the table, and the table pushes back up. That back up push is normal force. So how much friction this is gripping this on the paper, notice the paper moved before the calculator did, depends on how hard the paper and the calculator are pressing against each other, doesn't it? So that's what it says. All right, so there's a formula for that. Did you know that? There is a formula for this. It says coefficient of friction is the ratio of the frictional force between two surfaces and the forces pushing the surface together. In other words, we find the force pushing them together is found by the mass times the acceleration. In other words, the force of friction, which we write as this way, is the coefficient of friction times the normal force. Well, guess what? The normal force is the mass times gravity. But the normal force is only the part of the force that's straight up. Now, let's look at an example here. It says, consider a person pulling a 7-kilogram wagon with a constant velocity as shown in the diagram. Okay? The person is pulling with a force of 25 newtons, and the wagon handle makes a 40-degree angle with the horizontal. It says, what's the coefficient of friction for this situation? Now, what we have to do is, it says sometimes you can use a force diagram. So what we have to do is we'd have to know two things. We got to know friction. Friction is going to be what's pulling backwards, okay? If the cart's going forward, what's resisting the cart going forward? A force going backwards. Now, that has to be equal and opposite the force going forward from this guy. Does that make sense? Do you see where vectors come into play here? Vectors come into play because this force that's being pulled is going at an angle, isn't it? So I have to figure out what that force is. That force is the x component of that 25 Newton pull, isn't it? So how would I figure out what the x component of that force was? How do we find the x component if we know the magnitude and the direction? We don't need to graph it, we just need its components. We need the x component of that vector. What's the formula for the x component? R cosine theta. So what is the R here? Yes?
Could you not do like cosine? You know what I mean? How we used to do it?
Yeah, that's exactly what we're doing.
How like, oh, yes,
It is. The cosine of the angle is x over 25, right? So we would cross multiply. So this is the force of friction, right? So we know that this is how it's going to work, guys. We're going to say that 25 times the cosine of 40 degrees is equal to the force of friction. Now, what did we say the force of friction was equal to? Mu sub k times mg, right? So if I want to actually figure out what that coefficient of friction is, all I have to do is plug in the other values, don't I? So I have 25 cosine of 40 degrees here. I don't know what the coefficient of friction is, do I? Do I know what the mass is? How heavy was the wagon? 7 kilograms, right? All right. And what's gravity? Anybody know what gravity is? Yeah. Anybody know what that value is? Look what it says. 9.8. So this is negative 9.8. In reality, though, we're just going to make it plus 9.8. We don't care about the negative. Don't even worry about that. Because they're equal, aren't they? So now how would we solve this for mu sub k? It's just an algebra problem, isn't it? Divide by both sides by 7 and divide both sides by 9.8. So can I solve that problem? I can, can't I? So what would it be?
Zero
0.28. Yeah. And believe it or not, that's about right. So why don't we try one more of these? What is the coefficient of friction for a person pushing a 25 kilogram box across the carpeted floor with a force of 75 newtons if the force is being applied at a 25-degree angle? What's that going to look like, guys? We always draw a picture. I've got a box. What am I doing? I'm pushing it, aren't I? I am pushing this box at a, what's this angle going to be right here? 25 degrees. What's my magnitude of this force? 75 newtons. Okay. Now, if I'm pushing the box this way, which way is friction pushing back? The other way, isn't it? This time friction is going that way against my push. But they're still equal and opposite, aren't they? So what is my component right here going to be? What is this component? What would the formula be? It's the x component, guys. Cosine 25 degrees. Okay, so we're going to set 75 cosine 25 degrees equal to what? Why is my child calling me? Oh. Hello? Uh-huh. What's up? Okay, that's all right. Bye. My child thinks I don't work. I think that's wishful thinking on his part. All right, so what would this be? Mu times what? What's the formula? Mu sub k times mg. So what is the mass this time? 25, and what is g? All right. Can you find the coefficient of friction? Point what? Think they're all going to be 0.28? No, but it's pretty common. Coefficient of friction is always less than 1. And kinetic friction is going to be usually about 0.2, 0.3, 0.4. Okay? All right. Any questions about another way we can apply vectors? Don't forget about the way you know how to apply vectors, guys, okay? This one, if you look at number 16, it says you got Henry lifting a stone statue and moving it to a new location in the garden. Anne is pushing the statue with a force of 120 newtons at a 60-degree angle. Henry is pulling it with what is the magnitude of the combined force? In other words, she's pushing it, he's pulling it. They're going in the same direction, aren't they? How do we figure out the magnitude? We're going to have to take both of those and turn them into their what? Component. Yeah, their component form, and then add them. If we, after that, it says what's the magnitude, then we have to take these two and find the absolute value, don't we? Okay? All right.